This week we're going to talk about deburring. What a boring topic, some people say. And they're right. But it is important. So let's talk about it and understand it once and for all. The deburring I'm talking about here has to do with the action we need to take after drilling a hole through a metal, like the aluminum we use in our aircraft construction. For my little demonstration, I want to rivet these two pieces of aluminum together. I got the 3 holes and I'm going to overlap them and rivet them together. But one difference is I'm going to put washers in between the 2 pieces that I'm going to rivet together. I'm going to put washers right where the rivets are going to go through and sandwich these washers in between the 2 pieces. Now I'm going to go ahead and rivet in all 3 holes. And there's my final piece, 3 rivets, and if you look closely you can see the gap in there. Why the heck did I put 3 washers in between the 2 pieces I wanted to join together? And it's to illustrate what a burr can do around the hole. What we notice is that the 2 sheets are not in contact with each other, maybe in between, but certainly not at the locations where the rivets are trying to clamp the pieces together. Remember, the rivet is squeezing or clamping our 2 components together, and the clamping friction between the pieces accounts for about 15% of the strength of the bond between these 2 pieces. So that means we have lost 15% of the strength because we have lost the clamping pressure between these 2 components because we separated them by washers. And that's what happens when we leave a burr at the hole where we put a rivet through. We hold our 2 pieces apart and lose the clamping friction strength that comes from squeezing them together when we rivet. Plus, the bad news doesn't end there. Now, I used washers, and those washers will never fall out. But if you have a burr at these locations, we know the burrs are not attached very well, and they will crumble, and eventually, through all the vibration and flexing of your aircraft, they will break and fall off. Then what do we have? We have a loose joint. It would be as if I magically made my washers disappear if they fell out. Now we have a gap, so these 2 pieces can move all around and flex because we don't have that solid piece in between. So that situation is even worse than having a solid washer in between. With all of that flexing and motion over long periods of time, and especially in an environment like an aircraft where there's vibration and motion, the part will fatigue at those locations because of the minute amount of motion that is allowed. So the moral of the story is, for the tightest bond between 2 pieces of components that you're trying to attach together, always deburr so that the 2 components can be tightly clamped together and gain the full strength that you want. And it's not just rivets that we use as fasteners. When we drill holes for bolts, the principle is the same. We want the maximum clamping pressure, and that can only be obtained if the metal parts are properly deburred before assembling them. A tool commonly used for deburring holes is this countersinking tool. It can be effectively used if it is rotated no more than 1 or 2 times around. More rotations than that, and it starts to countersink, which is not something we want with thin materials. available at all fine aircraft tool supply stores. In a production environment, a fast and effective method is to use a flat file. In this case, we broke off a piece and glued it to a wooden handle. Watch how fast this works. And that's it. That is nice and smooth. One of the other benefits of using the file is that there is absolutely no chance of countersinking the holes in this thin metal because it's all done on the surface. So it's actually a preferred method if you're able to do it this way.